Okay, this should be lecture 15. Actually, we're going to make sure. Now it's bothering me. It's bothering me. I can't find it. Yes, it's 15. Okay, this is 15, Diffie-Hellman. It's actually very simple. Okay, it's a good idea we get it done with early. Okay, here's how it works. Alice and Bob share G and P, which is called a Diffie-Hellman group. Again, this is another story that if you read it out of that crypto book, it's amazing. It's like when they thought this one up, they're like, ta-da, the light bulbs are on, and it's still used to today. Still used today. So Alice and Bob share a Diffie-Hellman group, G and P, a large prime and an integer. Okay. Alice normally chooses G and P and shares with Bob. Okay. Alice and Bob do a lot of stuff with encryption, and Eve's always listening in. So Alice generates a large random number X, then sends a half key X to Bob. Okay? Bob generates a large random number Y and sends the half key Y to Alice. You notice how they did not share X and Y, the small X and Y. They shared the half key X and Y. Okay? So far, you with me? Let's see how it works. So Alice and Bob. It's funny. Casey and them had to use, Casey and David had to use calculators the other day in some class. And you're young. Do you ever take the calculators and write Shell Oil and boobs and stuff? They were so happy and they're like, look, boobs. I'm like, I did that in like what, third grade? Second grade? Seriously? Okay. So Alice and Bob compute the key. So they already received the half key. Now they compute the key. Okay, let's talk about why this is good. Key K is at least as strong as the strongest half key. Neither Alice or Bob can completely sabotage the resulting key. They can't screw it up. Disadvantages is no authentication. We don't know who did it, so there's no prevention of replay and no prevention against denial of service. But it's a way of sharing something over the internet. This is actually how poker's done. Okay. Here's an example. Consider a Diffie-Hellman scheme of G is 3 and P is 353, where Alice and Bob picked 97 and 233. Compute the half keys, X and Y, and then the key. Let's look how that works. So, here's the math behind it. X is equal to G to the X mod P. So, we go, remember G was 3, and Alice chose 97. So 3 to the 97th mod 353 gives us 40. Okay on the first line? So X is 40. Second line, G to the Y. So we go 3 to the 233 mod 353 is 248. Then the key, what now? 233 is right there. It's the Y. Remember, Alice and Bob picked 97 and 233. Okay. Actually, let me write that down so we can walk through this. So we start with G is 3. I know people online can't see this, but it's okay. And P equals 353. That's what he X equals 97. That's what she did. And Y is 233. Okay. So I can write it on notepad here, but still would get rid of it. So who picked what? Actually, let's Alice picked 97. Bob picked the other one, and they both picked the top. Okay. So 3 to the 97th is what Alice picked, and she calculates the 40. Bob picks 3 to the 233, and the 3 and the 353 are the ones they shared. Okay. They did not share the 97 and the 233. Those X's and Y's are not shared. Okay? So we get a 40 and a 248. And we share those. Okay? So Alice sends the 40 to Bob, and Bob sends the 248 to Alice. So then now 40 to the 233. Remember we had the 97 and 233. So 40 to 233 mod 353 gives 160, and 248 to the 97 mod 353 gives us 160. You notice they're exactly the same. I see that? They're exactly the same. So we're able to share 160. And yet we never knew the whole answer. So Alice and Bob each calculate only one half of the key at the top, okay? But their half will generate 160. So they will both match. And yet they never gave away their whole number. Everybody see that? It's really, 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 really simple to do. Okay? So, here's another one. Consider a scheme of G is 2 and P is 11. Where Alice and Bob pick 6 and 8. So, 6, 8, 2, and 11. So, Alice did 6, 8, 2, and 11. Okay. Okay, so 2 to the 6th, mod 11. So Alice builds in that number. She builds the 9. And Bob, 2 to the 8th, mod 11 is 3. They share those. Then 9 to the 8th, mod 11 is 3. And 3 to the 6th, mod 11 is 3. And we have the same key. That's all it is. That's the entire thing. Nothing else. Go home and walk through the assignments. You'll understand it better at that point. But it's really pretty basic. The problem is here, you're seeing both sides of it. But in the real world, you wouldn't see both sides of it. You would see the 2 and the 11. Then you would either see the 6 or the 8 at this point. You wouldn't see both of them. Since you can see both, you can see that they both match. But in real life, you would only see one of them. But the other person would see the other one, and it would match. Because in the real world, you'd only be coming up with one of the keys.
So if they both match, wouldn't you come up with both keys?
Well, that's right. You are. That's the point. They should match, as long as you did it correctly. Now, when you guys do your assignment, you need to calculate both. Easy enough? Pretty simple stuff to do. All right. That was 15.